Okay, so now I am differentiating. So d by dx of differentiating with respect to x. Differentiating with respect to x. Okay, so if we differentiate with respect to x, then d by dx of root x minus d by dx of 1 by root x. 1 by root x. Okay, here either we can convert this, okay, so into the power, or directly also we can apply the formula. Okay, so now I am converting now. Okay, now d by dx of root x I am writing as x to the power 1 by 2, x to the power 1 by 2, and d by dx of 1 by root x. 1 by root x means x to the power minus 1 by 2. Okay, 1 by x power plus 1 by 2 plus 1 by 2 taking to numerator means, okay, so we get minus 1 by 2. Okay, so now I am applying the d by dx of x power n formula here. D by dx of x power n is equals to n into x to the power n minus 1. Okay, so if we apply the formula, okay, 1 by 2 into x to the power 1 by 2 minus 1. 1 by 2 into x to the power 1 by 2 minus 1. Okay, so minus 1 by 2 into x to the power minus 1 by 2 minus 1. Okay, so now 1 by 2 as it is I am writing here. Okay, so x to the power LCM is 2, so 1 minus 2, 1 minus 2, and minus into minus plus 1 by 2 into x to the power LCM is 2, minus 1 minus 2, minus 1 minus 2. Now, okay, so this is equals to 1 by 2, write the 1 by 2 as it is, and x to the power minus 1 by 2. 1 minus 2 means minus 1 by 2 plus 1 by 2 into x to the power minus 3 by 2. Minus 3 divided by 2. Okay, so if you take from numerator to denominator, it becomes positive. So 1 by 2 into 1 divided by x power plus 1 by 2. Okay, so 1 by 2 into 1 divided by x power plus 3 by 2. Okay, so finally we can write it as 1 by 2 root x. This is root again. Power 1 by 2 means root we can write. Okay, so for the second one, either we can write in the form of root x power 3, root of, okay, so x under root of x, okay, x cube, or otherwise just keep it like that, x to the power 3 by 2. Okay, so this is the final answer. So what concepts we used here? Okay, here we used the x power n formula, and okay, so d by dx of x power n is equals to n into x power n minus 1 formula. Okay, so after that the simplification, and here we use the formula a to the power minus n is equal to 1 by a to the power plus n. 1 by a to the power plus n. Okay, minus n I am writing as plus n. Here also we did the same thing. Power 1 by x power 1 by 2. Taking to numerator means minus 1 by 2. Minus 1 by 2. Okay, so next 2 into x to the power 1 by 2 plus 6 into x power 1 by 3 minus 2 into x power 3 by 2. Okay, so this question also I am differentiating with respect to x. Differentiating with respect to x. Okay, so if we differentiate with respect to x, we write the d by dx of, okay, 2x power 1 by 2 plus 6 into x power 1 by 3 minus 2 into x power 3 by 2. Okay, so write the d by dx for each and every term. D by dx of 2x power 1 by 2. Okay, so plus d by dx of 6 into x power 1 by 3 minus d by dx of 2 into x power 3 by 2. Okay, after that the next step, what is the next step here? Whatever the coefficient we have, we write the coefficient outside. Okay, I am writing the coefficients outside. Okay, if we write the coefficients outside, 2 is a coefficient, I am writing the 2 outside. and d by dx of x to the power 1 by 2. Okay, plus 6 is a coefficient writing outside, and d by dx of x power 1 by 3. Minus 2 is a coefficient writing outside, and d by dx of x power 3 by 2. Okay, so now we can apply the formula. What is the formula? D by dx of x to the power n is equals to n into x to the power n minus 1 is the formula. Now I am going to apply this formula. Okay, 2 into 1 by 2, x power 1 by 2 means 1 by 2 into x to the power 1 by 2 minus 1. Okay, plus 6 into x power 1 by 3. 1 by 3 into x power 1 by 3 minus 1. Okay, minus 2 into x power 3 by 2. 3 by 2 into x to the power 3 by 2 minus 1. 3 by 2 minus 1. Okay, so now okay, so this is equal to here we can cancel. Okay, so by 2 table here 2 and 2 gets cancelled. Here 3 table, 3 ones are, 3 twos are, and 2 gets cancelled. So after that, okay, so we get this is equals to x to the power 1 by 2. Here LCM is 2 and 1 minus 2. Okay, so plus 2 is a coefficient, x power LCM 3. So 1 minus 3 minus 3 into x to the power LCM is 2. So 3 minus 2 we are getting here. Okay, this is equal to x to the power minus 1 by 2 plus 2 into x to the power minus 2 by 3 minus 2 by 3 minus 3 into x to the power 3 minus 2 is 1 by 2. Okay, so minus 1 by 2 we can write it as x 1 by x to the power plus 1 by 2. Whenever we have the negative sign, okay, in the power, okay, so take it to denominator, x to the power plus 2 by 3. Okay, minus 3 into x to the power 1 by 2 as this here. So power 1 by 2 means it is a root 1 by root x plus 2 divided by x power 2 by 3. Okay, just write it as it is minus 3 into x power 1 by 2. Either you can keep it like that or write it as root x. Write it as root x. Okay, so here we applied the formula. A to the power minus n is equals to 1 divided by a to the power plus n. Okay, the same formula whatever we are applying here repeatedly we are using. Almost we are using x to the power n formula in each and every problem. Okay, n into x power n minus 1. And almost we are using this concept also. A to the power minus n is equal to 1 by a to the power plus n. Okay, so these are the concepts we used in this, okay, solutions. And next question number 13. 3x power 7 plus x power 5 minus 2x power 4 plus x minus 3 whole divided by x to the power 4. Okay, so now I am differentiating with respect to x on both the sides. Okay, so I am writing the d by dx of 3x to the power 7 plus x to the power 5 minus 2 into x power 4 plus x minus 3 whole divided by x to the power 4. Okay, in the first exercise we don't have u by v formula. Whenever we want compulsory, then only we use u by v. Otherwise better to go for other alternative. Here we can use the concept. Okay, what concept we can use? The denominator we can separate for each and every term. Okay, for this term, for this term, for this term, for each and every term we can separate the denominator. Okay, so according to that concept, I am writing this x to the power 4 denominator for each and every term. So d by dx of 3x power 7 divided by x to the power 4 plus x power 5 divided by x power 4 minus 2x power 4 divided by x power 4 plus x divided by x power 4 minus 3 divided by x to the power 4. Okay, here we have the formula, another formula, that is a to the power m divided by a to the power n is equal to a to the power m minus n. Okay, we are taking the bases are same. Okay, we can subtract the power. Okay, one power from another power. Okay, a to the power m minus n, or 1 by a to the power n is equal to a to the power minus n. Okay, so we can use these two concepts now. Okay, so d by dx of, we are not differentiating. Okay, just the simplification part only. 3 into x to the power 7 minus 4 here, plus x to the power 5 minus 4 here, plus 2 into x power 4 cancel, so we get 1 here. Okay, and 1x cancel, or otherwise x to the power 1 minus 4 minus 3 into x to the power minus 4, taking to numerator means here we get the negative sign. Okay, it becomes negative. Okay, so now I am writing the coefficient outside. I am going to write the coefficients outside. So these are first we'll take one more step, or otherwise. Okay, so writing the d by dx for each and every term. Okay, so d by dx of 3 into x to the power 7 minus 4 is 3x power 3. Okay, plus d by dx of x to the power 5 minus 4 means 1, plus okay, d by dx of 2 ones are 2, plus d by dx of 1 minus 4, x power 1 minus 4 means minus 3. Okay, minus d by dx of 3 into x to the power minus 4, 3 into x power minus 4. Okay, so now this is equal to, here I am going to write the, okay, so coefficients outside. Okay, so whatever the coefficients we have, I am writing the coefficients outside and applying the formula here. Okay, so now 3 is a coefficient writing outside, and d by dx of x to the power 3. Okay, d by dx of x is equal to 1, plus d by dx of constant 0, minus plus d by dx of x power n into minus 3 into x to the power n minus 1, minus 3 minus 1, minus this coefficient writing outside, and d by dx of x to the power minus 4 as it is. Okay, so here we are going to apply, and we applied the formula. Okay, so d by dx of x to the power n is equals to, d by dx of x power n is equal to n into x to the power n minus 1. We are going to apply the formula in the first term and last term, and here already we applied. Constant derivative is 0. Now, okay, so if we simplify and apply the formula, 3 into, okay, so 3 into x to the power 3 minus 1. Okay, plus 1 as it is, minus 3 into x to the power minus 3 minus 1 minus 4, minus 3 into, okay, here x power minus 4 means minus 4, x power minus 4 minus 1. Okay, 3 3 is a 9 into x to the power 3 minus 1 is 2, plus 1 minus 3 into x to the power minus 4, take into denominator, becomes positive, x to the power plus 4, 1 by x power 4, minus into minus, plus 3 4 is 12, x to the power minus 5, x to the power minus 5. Okay, so now this becomes 9x square plus 1 minus 3 divided by x to the power 4 plus 12 in divided by x to the power plus 5, minus 5 becomes plus 5. Okay, so this becomes, okay, so required solution. Okay, here what we used here, what are the concepts we used here? Okay, so we do use the a to the power m by a to the power n is equal to a power m minus n, and 1 by a power n is equal to a to the power minus n, and d by dx of x power n is equal to n into x power n minus 1 formula, and d by dx of constant equal to 0, d by dx of x equal to 1. These are the concepts we used in this solution. Okay, do you have any doubts still here? For more educational videos on ISC, CBSE, ICSE, and all other state boards, intermediate, IIT-JEE, and EAMCET, BITSAT, and all others entrance exams as well as academic exams, please like, share, subscribe our VEDHA online classes. Thank you for watching.